Okay, guys, now that we've taken a look at some of the theory and mathematics behind the generation of curves, what we're going to do is apply some of that to our very own application.
That's right.
What we're going to do is we're going to take the base SDL demo app that we've been using time and time again, and we're going to, as a matter of fact, show them the application. Run it real quick. Here we go. Look at that. How exciting, right?
Yeah, very exciting.
We're going to take this right here. Let's go and close this application, and let's bring up the one that we're going to create. We're going to build this. We're going to show you how we can have 4 points and generate a curve from those points. Not only that, but go ahead and manipulate some of those points. Check this out. So in real time, as you go in here and manipulate the points, you'll see how the curve is being recalculated and redrawn.
Yep.
Actually, it's being constantly redrawn, but you get the idea.
All sorts of interesting things here. And what's really cool is taking what you learn here, you can convert, this is simply 2D example.
Right.
But you can easily convert this into a 3D example, having, full 3D curves going through 3D space with rotations as we've seen in the texture demo and all sorts of other demos.
Precisely. So this is going to be really cool. So this is what we're shooting for. Let's go ahead and close this. Now, the neat thing is, once you have an idea of how to go about generating curves like that, you're in awesome shape for putting curves for whatever you may need them for.
That's right.
Into your own applications. Animation curves, path curves, whatever it may be.
Yep.
Okay.
And in the last lesson, we showed you the direct mathematical approach to creating this curve.
Right.
In this one, we're going to utilize some of the utilities provided in OpenGL. From what we did in the last lesson, you can easily create your own functions if you wanted to. But I also want to show you some of the cool OpenGL utilities that allow us to do this easily.
It just simplifies things.
It does. And since it's there, might as well use it.
Well, we just got finished showing them all these different formulas that they can use. They can simply just plug those in.
That's right.
So, it is OpenGL. The whole idea is to make graphical programming a lot easier.
That's right.
So let's take advantage of it.
Precisely. So the first thing we're going to need to do is create a variable that holds the different control points. I'm going to have 3D control points, so they'll have an X, Y, and Z. And as you saw, we had 4 of those.
Right.
So we need a multi-dimensional array.
Right.
So a GL float. We'll just call these control points with 4 and 3.
Okay.
And we're going
to 4 points each with 3 pieces of information, X, Y, and Z.
And then we're going to have 2 integers that specify whether or not which vertex we currently have selected and which one we're hovering over. Because you may have noticed when I hovered over it, it had one color. When I selected it, it had another color.
Right.
So int hovered is going to have an index into which current point is being selected, so from 0 to 3. And then we're going to have an int selected.
And we're just setting it to -1 because nothing's being hovered over it or selected at the moment.
Exactly. And then let's go down to the initialization. So in initGL, we're enabling textures, but we're disabling GL lighting.
Okay.
Because it's going to be a 2D scene.
Right.
What we're going to do is initialize our control points to something. So we have our control points. Let's see. We'll start out with 0, 1.
0 and 0 for X. We'll set it to 50.
Yeah.
And arbitrary numbers that we've selected we thought would be good.
Yeah.
So, yeah, all we're doing is changing X,
values.
Y, Z, and 50, 50, and 0.
Z's going to be 0 for all of them.
That's right. Absolutely. Copy, paste. And now all we need to do is worry about changing that first index. Beautiful. Oh, yeah.
Oh, yes, one more time.
And nice. So now we have all 4 points.
And let me just put some other values in here. For X is going to be 30, and for Y, I'm going to just take the window height and divide by 2, so it's going to be in the middle of the screen. And then this is going to be 90 for the third point, and then window height divided by 2 as well. And then for this one, I'll just do window width -50, just to keep it away from the far right edge. And then 50 for Y.
Okay.
So this is just something we can initialize.
You can play around with these numbers. I mean, that's all. You're just giving it a default curve to start out with when the application launches.
That's right. So let's go ahead and get this curve drawn out, and then we'll go ahead and add in the manipulation code. So if we go down into our draw scene here, right now it does nothing but clears the screen, sets it to an orthographic view, and resets the model view matrix, and then draws the frames per second. So let's go ahead and first do a few things. The first thing is we need to enable GL map 1 vertex 3. Okay. And let me just go ahead and type this out, and then I'll explain exactly what this means here. GL map 1, this allows us to enable mapping of a vertex 3 for curves. So this is vertex 3, we have X, Y, and Z, this is 1 because remember we had the T, which goes between 0 and 1.
That's right.
If we had 2, that would be U and V, which would define a surface for us.
Gotcha.
So in this case, we want a simple 2D curve, so we just have 1.
Very cool.
And we also want the line to be fairly smooth, so what we're going to do is do a GL enable GL line smooth.
Simple enough.
And do a GL enable GL blend, because without blending, the lines wouldn't be able to be smooth, so you need both. And let's go ahead and set the blend func as well.
And we've already seen this before. This is nothing new. Source alpha and then 1 minus source alpha.
Alright, so once we got that, let's go ahead and we've already disabled lighting. Let's go ahead and actually initialize our map here. So what we're going to do is do a GL map 1F, GL map 1, vertex, just like what we typed up here. In fact, I can just copy and paste this in here. And let me go ahead and bring up the help here so you can see the function definition for this.
Okay, good
and
idea.
I can explain exactly which each of one of these is doing. So if I bring this up here, alright, 1F. So as you can see here, we have the GL map 1 vertex 3, and we also have a GL map vertex 4 here, and some people might wonder, why would we have 4? One reason people do this a lot is because this determines how it's incremented inside when it's going through each of these points. So you can store an extra piece of information in the 4th element if you really wanted to. So when you're passing information, you could get that information from it. So that's just one reason for the target. And for U1, again, this is simply going to be from 0 to 1. This is specifying the range. For our case, we're going to have U1 be 0 and U2 be 1. So it goes between 0 and 1.
Okay.
Stride, this is necessary because, as we mentioned up here, this says vertex 3 and vertex 4.
Mm-hmm.
You're going to have, how many floats do you have per element? In our case, we have an X, Y, and Z, so that's 3. If you had 4, that would be X, Y, Z, and some W component maybe.
Gotcha.
So that would be 3 or 4.
And in our case, 3.
In our case, 3. And the number of control points, of course, in our case, we have 4.
4, right.
And then finally, the array, which in our case is control points, Steve.
Right.
So once you know what that is, this is really simple to do. This is, of course, the first U1.
Start at 0, we go to 1. It's going to be 3, X, Y, and Z.
Yep.
We've got 4 control points, and then we can just pass the address of control points.
Yeah,
and
so first
0.
element.
That's right. Perfect.
And let's also go ahead and set the line width, because we're about to draw this actual curve.
Mm-hmm.
So let's set this to like 1.5F. All right. Now here's how difficult this is going to be. Check this out. We'll do a GL begin, GL line strip.
You want to set some color first?
Yeah, let's also set it to a white color.
Yeah.
GL color 4F, 1.0F, 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 1.0F. In fact, I could have just did 3F, but anyways.
You just like it.
Yes, I do. What we need to do is determine the number of segments that we want. In fact, let me go ahead and come up here and just define a constant int num segs, and I'll set this to say, let's say 40.
Okay.
So this is the number of segments that I want. And then all I need to do is say I is less than num segs.
Right.
So that's going to say how many segments do I actually want in my curve.
Increment through I.
Increment through I.
Nice. Oh boy, here comes the hard part.
GL eval chord 1F. And then all I need to pass it is a U. And that's going to simply be a float I, which is what we're looping through, divided by num segs.
Mm-hmm.
And let me cast that over to a float as well. That's it.
I don't know, man. That's pretty complicated.
Well, see, what's cool about this is basically what GL eval chord 1F is doing is calling GL vertex 3F and passing the coordinates which is generated by our mapping.
Mm-hmm.
So we've defined the control points that GL map 1F is going to use. Every time you call GL eval chord 1F with a particular value between 0 and 1 in this case, it's going to call GL vertex 3F with the position at that particular point. So we don't need to call GL vertex 3F. We don't need to do anything. It's all done right there.
Very nice.
So actually, let me go ahead and compile this. Let me go ahead and run it and see if we get anything. All right, so what we have here... Psychedelic. Seems like we're having a little bit of problems. It looks like the texture is still being used.
Okay.
So we need to disable the GL texture.
Scroll back down real quick. I just want to see something. Do we also have a GL end anywhere for
No, I think. Oh, what am I? Oh, I don't have a GLN.
Yeah.
Thank you. I think we also need a disabled GL texture. Because remember, when we go back to the drawing of the FPS, we're using a texture.
Right.
The line does not need a texture. So, GL texture. I thought I threw that in there already, but I was so excited about the map 1F. So look at that.
Much better.
So we have our demo here. We have a nice looking
you
curve.
got to admit, the psychedelic curve was pretty cool.
It was pretty cool. It was blinking and everything.
But we got a curve. Awesome.
Yes, we do. Let's go ahead and throw in the control points so that we can start manipulating those as well. And then we'll write the manipulation
code. So we're just going to
to
drop some points in, some GL points, basically.
Yeah, so we'll do an int I equals 0, I is less than 4, I plus plus.
Meaning we're about to create 4 of something.
4 something. Let's do a GL point size. We'll set this to 5.0f, or, 5.0f, and we'll set the color of this particular point to 1.0f. And this is where we'll be adding the extra code when something's selected, when it's hovered, etc.
Right.
GL vertex 3f. Actually, let me go ahead and add in my GL begin and end.
Good.
Not forgetting my GL
Don't worry,
end.
I wasn't going to let you get away with it this time.
Yeah, I know. No.
Points. I could wait till you're done, but
awesome.
It just looked pretty cool.
GL point.
Yeah.
There we go.
Now we're talking.
So in the GL vertex 3f, I'm going to do a control points, I, which is the one we're worrying about, and then x, y, and z.
That's right, as we walk through each point.
Yep. And of course, if we had more points, we simply increase that.
So 1, and then finally control points I and 2. Nice.
There you go. Very simple. So let me go ahead and make sure this works. In fact, this is going to bring up an interesting thing as well. Let me increase the size of that, because that's really small. Let's see. Geo points. I'm sorry for the pause there.
Here, we can do is before the begin.
Yeah, let me just throw this in here. I thought I already had that. Let me go ahead and make sure I wasn't doing something. Okay, there we go. Notice this. We go from this point to this point to this point. As I mentioned in the last video, it always is supposed to end at that point.
Aha, that's true.
This is not really that complex. All I did was, because I'm dividing I by num segs, I is never going to reach num segs. It's going to be num segs minus 1.
Short.
Yep, it's never. This value is never going to reach 1. So I'll simply change this to less than or equal
to, and life is good.
And bingo.
Ooh,
done.
Hey, bingo. How you doing? Very nice.
So now all we need to do is go into our update navigation, which we used before to, update the navigation, change the viewport around, the rotation in X and Y. In this case, we're going to just modify the curve. So starting with this, let's go ahead and start out by setting hovered equal to -1. Because this is going to change.
Hovering over nothing.
Hovering over nothing. This is going to change constantly.
Right.
So first thing we need to do is loop through every single point and see which point we're hovered over. So do a int I equals 0, I is less than 4, I plus plus. And then if, we need to check if we're close or not to that particular point. So what we're going to do is take control points. We're only worried about the x and the y, remember? So with x, we're minusing by the state.x, which is the current position of the mouse. We want to see if this value is less than 5. We want to take the absolute value because on the left or right.
Okay.
So we'll do an FABS, which is the floating point absolute value function. If that is less than 5, which means we're in a 5 at radius of that particular control point, and the FABS of the y with the y position of the mouse, so y minus state.y, then we know we're hovered over that particular point. So hovered equals I.
Except for, if you don't mind, jump back up. We got to finish that off. If it's also less than 5.
Oh, did I? Wow. Okay.
It's late. It's all good.
So less than 5.
There we go.
In fact, to make this really clear, if I had done this in the first place, I wouldn't have made that mistake.
There we go.
There. Now very clean. So let me see. Now we have a hovered now holds which vertex we're currently hovered over.
That's right.
Now what we need to do is see if the left mouse button is down, and if so, select that point and start dragging it around next time we move.
Okay.
So if state.left button down, we need to check whether or not he's navigating. So if he's not navigating, in other words, he's not moving a point around, then selected equals the current hovered item.
That's right.
And then let's go ahead and grab control, as you saw many times in the past. So SDL grab on. So we take control of the mouse. Then we'll say if selected does not equal -1, which means we do have a point selected, or greater than or equal to 0 if you prefer.
Mm-hmm.
Then we're going to move control points at selected. Which control point do we want to change? Selected.
Mm-hmm.
Change its X component to the current mouse
Right.
position.
And same thing for Y.
Yep. Very straightforward stuff, but interesting nonetheless. And then we want to set...
we are navigating.
Yeah, we want to make sure navigating is set to true. Navigating equals true. Otherwise, we want to, if we're navigating, and we don't have the mouse button down anymore, we want to stop moving the button around. So, whoa, stay dot, left button down. I can do it, really. So let me go ahead and finish that up here. Then, if the left button down has no longer been selected and we're navigating...
We're no longer selected.
Right.
So we'll set that back to -1.
Right, because basically what happened was, while the left mouse button is down, it's going to come inside of here. And the moment we let go, we know left mouse button up was just happened.
That's right.
So we need to stop selecting. So set selected equal to -1.
Right.
Navigating equals to false. And set our SDLWM grab input to false. Grab input to SDL grab off.
Now, at this point, all we really need to do is go back and update when we draw our points.
Oh, exactly.
So that we can control the color based on what selected and hovered set to.
That's right. So let me go ahead and just do it. If equals, if the current point we're about to draw is equal to the selected one, do something. So
we'll make it a little bigger.
Make it a little bigger.
Change its color to like red.
Yeah. So do a GL point size 6.0F. GL color 3F to 1.0F, 1.0F. Oh, sorry.
Yeah, 0.
So a red. And
otherwise,
else, if it equals to hovered,
we'll make it slightly bigger with 5.5 as our size.
And let's see. Let's just make this a little bit brighter. So like a pinkish type color.
Exactly.
Otherwise, we'll just set it to the default. So let me just take this, put it here, and we'll take the...
Grab our point size from up there.
Yep.
Beautiful.
Awesome.
That's about it there.
So let me go ahead and compile this. I think we should get an error. Yes, FABS not found.
Oh, gee, I wonder why.
Well, let's see.
Include. All right.
Done. Sorry.
Wow. Up.
And let me go ahead and get rid of these.
Yeah.
Because I don't like these. Notice, remember, our control points are floats. So let's go ahead and cast these over to GeoFloats.
Nice.
And with that, that's done.
Nice and clean. All right, what do we have when we run it?
Bing.
Ooh.
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 Oh, nice. Another thing I just noticed is the size doesn't seem to be changing. It doesn't seem. What we need to do here, this is a very simple thing. Inside each of the loops, when you change the size, you need to go ahead and start again. You can't, for points, you can't be in the same loop and change the size within the loop. And that's why it didn't work at first. So let me go ahead and recompile that. So as you can see, the points are really small, and I'm not changing the point size until after. So let me go ahead and do that. So when I move my mouse over, now it gets bigger.
Nice.
And when I click, it gets a little bit smaller.
No, it gets even bigger.
It gets even bigger.
That's right. I was going to say, you losing your mind there, Joel? Very nice.
So there we have it, a completely functioning curve. And again, I mean, using these same methods, you can create NURBS patches. Patches for just by simply changing.
So what if we took our number of segments way down?
If you'd like to what? Oh, okay.
Yeah, just thinking of some things just to show them.
Sure, let me change this to 10.
Ooh, yeah, there you go.
I thought you meant control points, and I was like, that actually requires more work. So as you can see, you can actually...
So for those of you that work in Maya, or other applications, but let's just say in a 3D application, you may be familiar working with like NURBS curves or splines in general, and low res. I'll pick on Maya. You get curves that look like this, and you hit 3 to update the resolution of it, and what is it doing?
Adds more segments.
Adds more segments. So now you guys know how to do something like that.
Exactly.
Well, that's pretty cool.
And another thing, just to kind of emphasize this a little bit, we can change this to enable GL map 2, and change this to map 2F, change this to map 2, and what that allows us to do, as I mentioned before, is allow us to create a NURB surface. This is just curves, but if you have more than that, you can create an entire surface. And by simply mapping, going through U and V instead of just T, we can have an entire surface mapped out. And that's how that works as well.
Awesome, awesome. You know, for those of you that are watching this video, if you'd like to try something, we've already shown you how to go about creating your own custom controls. Why don't you try putting something like a slider in that allows you to control the
number of segments.
It's for those of you looking for a little challenge.
Or a number of control points.
Oh, yeah, there you go. Or perhaps even a button that'll let you add more or something.
Exactly.
Or take them out as well. All of these things should be super, super... I mean, I'm ready to get started right now. All that should be super easy with everything we've shown you so far. So, Joel, unless you have anything else to say, I think that's pretty much going to wrap it up for curves.
Yep.
All right, guys, thanks a lot for your attention, and that concludes this lesson.